blue. There, it's on. Okay. All right, here we go. Graph f of x equals the square root of x, and it says find the domain and the range. So let's write ourselves a note. To find the domain of a square root function, and we've already talked about this, but we're going to state it again. Step 1, set the radicand greater than or equal to 0. Step 2, solve for x. So tomorrow, or I guess on Monday, before you say to me, I couldn't do the domain, I don't know how to do the domain, I'm going to direct you to your notes. I mean, I'm putting all the steps there for you. Now, what's a radicand? The stuff under the radical, okay? So we're going to start off with the domain. There's only an x, so that's why it's x greater than or equal to 0. I'm going to pause and wait on the range till we're done, okay? And then we'll finish that up. Now, for square root x, the first number, the smallest number you can plug in is 0. And if I plug that in, I get 0. If I do 1, the square root of 1 is 1. Now, instead of just going 0, 1, 2, 3, you need to think here. If I plug in a 2, what's the square root of 2? It's the square root of 2. It's some decimal. It ends up being 1.41 something, but it's not a nice number. And square root 3 is not a nice number to do. Square root 4 would be a nice number. What's the next nice number to try? 9. And then, because we don't want to go that far on our graph, what would be the next one? 16. All right, we're not going to put that one. So, think about your graph. I don't need any negative x's, so I'm going to slide the y-axis further to the left. I don't need any negative y values, so I can move the x-axis down. And then remember to label your tick marks in such a way that's indicating where you're going by 1s or 2s. And you're going to see shortly why we might say that. So now let's plot these. I have 0, 0, 1, 1, 4, 2, and 9, 3. So something I want you to notice about this graph is it has a starting point. It doesn't have arrows going like our lines or our U's or our V's. This is a square root function. And so here's why I have this caret in my tool belt. I want to give you a visual, and the funny thing is, then pre-calc students are like, oh yeah, they talk about it, and even in calculus they talk about it. So it's a good visual to help you. I want you to imagine, okay, think of a carrot like Bugs Bunny, if you ever saw Bugs Bunny. Okay, imagine your carrot is in the ground in your garden, okay? So there's your starting point. Okay, it doesn't go forever, it only grows to a certain point. But then you're going to reach down and you're going to pull the carrot out of the ground, and I want you to look at the motion of that pull. If I pull it, it comes up and it would sort of level off. And so that's, to get all the way to 16, it's going to take a long time to go up to 4. So what we're going to do is we're going to call this, instead of a caret, it's our root. It's our square root, our root. But I want you to think of a carrot in the ground, so it has a starting point, but the motion, pulling it out, it comes up kind of rapidly, but then it would level off as you pull it all the way. Does that make sense? Okay, so this is our root. Now let's come back to range. What I want you to notice is this is called the parent function for square roots, but this is increasing. It doesn't increase very fast. It's very, very slow, because then the next one's 25, 36, and they get further and further out there. But it is constantly increasing. the parent function. So there's a lowest y value is 0, and then it goes up. So my range are the possible y values, or the outputs. So my range is y is greater than or equal to 0. Okay? You are going to want to remember this. This is going to be your standard table for square roots. 0, 1, 4, 9. And you just have to remember, okay, those are perfect square numbers, the first 4. All right, now we're going to look at y equals the cube root of x. Find the domain and the range. Well, we've talked about these before. Odd roots, domain is all real numbers because I can plug in, say, the cube root of negative 8. What's the cube root of negative 8? Negative 2. What's the cube root of 64? 4. And I said positive 64. Cube root 64 would be 4. And then what's the cube root of negative 125? Negative 5. So I can put positives and I can put negatives and I still get outputs. Okay? So domain and range of odd roots will be all real numbers. So that's easy. And I heard somebody say yesterday after our quiz, they said on the quiz the domains, they just guessed all real numbers. That's not a bad strategy if you're desperate. Put all real numbers. You got, a 50-50 shot there. All right, now I want you to look at the table that I'm using for my cube root. I have negative 8, negative 1, 0, 1, and 8. Why have I selected those numbers? Carmel?
Because those are the perfect cubes.
Yeah, they're all perfect cubes. So the cube root of negative 8 is negative 2, negative 1, 0, 1, and 2. Unfortunately, I can't do the x values by 1, so I'm going to have to go by 2's. So you may have thought I was silly to keep asking you to indicate your scale, but it's because I knew where this was headed, that eventually you're going to have to go by 2's or 3's or 5's. So if we practice it from the beginning, we'd be fine. On my y-axis, I'm going to go by 1's. And then we're going to plot this one. I have negative 8, negative 2. Be careful with negative 1, that's left halfway, but down 1 tick mark. 1 comma 1 is right halfway, up 1 tick mark, and then 8 comma 2. Sometimes students think this one looks a little bit like a snake, if that will help you. But I do have a visual for this one. Is if you think about, a die, it's sometimes called a number cube. And what I like to visualize with this one is if I'm standing at the edge of a table. Okay, I'm standing here and there's my table. So I take my cube, my number cube, and if I toss it onto the table, the motion would then fall and then roll onto the table, right? So can you see that? That if I take my dice and my number cube and I toss it, it's going to flow like that. Notice it is constantly increasing, but what's the next perfect cube number after 8? 27. Do you know that's like way out there to get it to move? So it is leveling off, but don't make it look like it's going down. It is eventually going to keep going up, but also don't do this where you make it look like that, because that's certainly not true, okay? So domain and range are all real numbers, and this is going to be your standard table. So now what we're going to do is we're going to do some transformations with this. Okay, this is an even, this one's a square root. So to do my domain, I set the radicand greater than or equal to 0. I'm going to pause on my range to see what happens. This is a square root. The standard table is going to go 0, 1, 4, 9. The only time we're going to possibly adjust the table is if you shift it left or right. So now we're going to plug these in. I'm taking 1/2 times the square root of 0. So that's 1/2 times 0, which is 0. 1/2 times the square root of 1 is 1/2. 1/2 square root 4 is 1/2 times 2, which is 1. You guys, on that composition of functions packet that I gave you guys, I saw horrible algebra on it. Just horrible. I cannot even begin to tell you. There was a problem, and I can't remember exactly what it was. You know, I mean, it could have been something like this. And I was mortified. I had several somebodies, multiply the top and the bottom by 4. Why on earth can you not do the top and the bottom by 4?
Because the 4 is really 4 over 1.
Yeah, 4 over 4 is not 4. I could not believe that. And then the other thing that I saw students do this. Why can I not distribute the 4? Please excuse my dear Aunt Sally, you have to do the exponent. I was like, that's pre-algebra. And the other thing that I saw was, I think it was like x plus 7 squared. And I saw people do this. And I was like, oh my goodness, that should not happen in algebra 2, okay? So as I was thinking of this, I thought, boy, I hope somebody's not trying to make that 2 over 2 there. All right, and then 1/2 radical 9 is 1/2 times 3, which is 3/2, okay? So let me erase that. Yeah, so there was some really bad algebra going on that packet. All right, let's make our grid. Let's think about it. I don't have any negative x values, so I'm going to move my y-axis left. I don't have any negative y values, so I can lower the x-axis. Indicate your scale.
Would it be okay if, like, the y's we just go by halves?
Yeah, you can do that, and then, like, maybe, let's do that. That's a great idea. I like that. I thought it, and then I didn't do it. I was like, okay. So you could do 2 tick marks and call that 1, and that's sufficient evidence that each tick mark is a half, okay? Yeah, I like that. So then let's do 0, 0. Then I have 1, 1/2, 4, 1, 9, 3 1/2. So then I think we can determine the range. This one's still increasing, it's still going up, so y is greater than or equal to 0. Now it does say compare it to the parent function. And I want to bring you back to our absolute values, our v's, or our parabolas, our u's. Do you remember when the number in front was between 0 and 1? What kind of transformation was that? We had a name for it. Henry? It's not a reflection if it's a negative. It's a stretch or a shrink, but yeah, which is it? Okay. Let's write this down so it's in our notes. Given y equals a square root x. If a is between 0 and 1, then it's a vertical shrink. So on this one, because it's not going up as high. If a is greater than 1, then it's a vertical stretch. So, since we have a 1/2, this is a vertical shrink. And what's really, really nice here is that that's not new. It is not new. We did this with b's, we did it with u's. We're going to continue to do this with exponentials and logarithms in chapter 7, our next chapter. You're going to learn about logarithms. It's very fun. And we're going to do it with trig, sine, cosine, tangent. It's all the same thing. The left, right, up, down, stretch it, shrink it, flip it. Okay? But now you should be able to look back through your notes and have this as you continue to learn it. All right, example 4.
We didn't do the range.
Oh, sorry. Thank you. thought I did, but maybe you didn't catch it.
Oh,
Yeah,
never mind.
I did. It was y greater than or equal to 0. Maybe I said it too quickly. I'm sorry. Now, can you think, do you remember how if you put a negative out front, it flips it upside down? And Henry used really good math vocabulary where he said that's a reflection. It's a reflection over the x-axis. So thinking about my square roots, you will have some square roots that are decreasing or falling if you put a negative out front. So don't always think, oh, square roots are always greater than or equal to 0. That's not true, okay? It depends. All right, so this is y equals negative 3 cube root x. So domain and range I can do easily. You're going to use your standard table. So I'm going to give you a head start, and I want you to plug in the x values and do the corresponding y values. And then plot it. Remember to indicate your scale, and unfortunately I have to go by 2's on the x and the y axis because I can't get to 6 on both ends, I don't think. Oh, maybe I could have. I'm going to still go by 2's. Alright, so here's negative 8, negative 6, negative 1, 3. So mine, if you did it by 1's, ours will look a teeny tiny bit different, but not tremendously. And so you need to have the general shape here that is looking like that number cube or your dice rolling, okay? It's got to have that shape to it. So if we want to compare it to the parent function, there's two things going on. You have the negative, that's one thing, and then the 3 out front is a second thing. So the negative gives me, and please don't say flip it, okay? We want to use proper mathematics. Reflection over the x-axis. And then what does the 3 do? We just covered it.
It's a vertical stretch.
It's a vertical stretch. Good. So if you have, and really we shouldn't be struggling with those because we did this with absolute values. We've done them with parabolas. Now this is our third time to go through this. However, having said that, if you are struggling with stretches and shrinks, make index cards. If A is between da-da-da and on the back, put what it is, and then study them, okay? There are things you can do. All right, graphs of radical functions. You're going to need to write down step 1 and step 2 into your notes. What's really nice as you're writing is that, do you remember when we talked about vacuum off and in socks only? I know that was very, very silly, but it was helpful. When we were talking about the vertex of our absolute value or the vertex of the parabola, vacuum off and in socks only represented it was the opposite of the inside, the same as the outside. So the H and the K are going to do the exact same thing. So when I look at example 5, this is going to be a shift. Right 3, up 2. Now I've got a vertical stretch and a reflection, but I already know all this. I'm just doing it now to a square root function, okay? All right, so step 1, you're going to ignore the H and the K, and you're going to graph either y equals a square root x or y equals a cube root x. Step 2, Then you're going to shift the graph h units left or right and k units up or down. Now this is one method. Then I'm going to show you a second method that some of you that are a little bit more advanced, I think you'll prefer that, where we can do it in one graph. So I'll show you both methods. So in example 5, I'm going to use what our textbook shows you. Step 1. And you don't do domain and range till the end then, if we're going to do the 2 steps. So we're going to graph y equals -2 square root x. You ignore the h and the k. We're going to ignore the -3 and the +2 on the outside. So the table for a square root is 0, 1, 4, 9. And now you're not looking at the original problem, you're looking at y equals -2 square root x. So let's plug those in. That would be 0, -2, -4, -6. Okay, I think I can go by ones, so let's try it. It'll be tight. And then what you're going to do, since this method requires you to actually draw 2 graphs, the first one, we're going to make it dashed, okay? So I'm going to plot 0, 0, 1, -2, 4, -4, and 9, -6. So remember what I mentioned previously was that it is possible to get a square root function to decrease, and that's by putting a negative out front. Oh nuts, I just said do a dash and I made it solid, sorry. So no worries, if we work in pencil we just erase, not a problem, okay? Okay, do you guys see that one's dashed? Okay. Now I'm going to go ahead and just switch colors. Step 2 says you're going to do the shift. Well, looking at it, it's right 3. Remember, it's the opposite of the inside, same as the outside. So it's right 3, up 2. So I'm going to take every single point and move them right 3, up 2. Right 3, up 2. Right 3, up 2. Right 3, I'm going to have to make an extra little tick mark, up 2. Then make your second one, your final one, solid. Does that make sense? You're doing y equals -2 square root x, make it dashed, and then you shift every single point, right 3, up 2. Now we can handle the domain. The domain is still x minus 3 greater than or equal to 0. So x is greater than or equal to 3. My range, the highest y value is 2, and then they fall. So this is y less than or equal to 2. Now there is a way to do this without the graph. The domain is like we just did. You set the radicand greater than or equal to 0. To figure out the range without the graph, you look at the k value, and that's either the lowest or highest value. If it's negative, and the a is negative, it's falling. So that means 2 is the biggest. If this had been positive 2, it would have been y greater than or equal to 2. Then it would have gone up. Does that make sense? Cool. All right, it did not ask me for the transformation, so that's okay. All right, let's try another one. Example 6. I can do domain and range on cube roots. Those are easy. Step 1. You can graph y equals 3 cube root x, and then step 2 is shift left 4, down 1. Now, for those of you that would like to try a more advanced method, here's how you can do it with one graph instead of doing that. What you would need to do is you recognize that you have a cube root, and I personally do it this other way. I don't do it the way our book shows. Here's what I do. I know that a cube root has -8 to 8. But since it's being shifted left 4, I just take my table and I shift all the x values 4 to the left. And make one table, and that's my final graph. Like, I don't fill in the y values on the standard one, because I just need to remember what are those x values. Okay? So you choose your method. I'm going to go ahead and finish it the second way. So this would mean I have 3 times the cube root of -12 plus 4 minus 1. Well, that's the cube root of -8. That's -2. -6 minus 1 is -7. And then I can actually do all those in my head. -5 plus 4 is -1. That's 3 times -1. -3 minus 1 is -4. -4 plus 4 is 0. Oops, I forgot to subtract the 1, sorry. Got it. It's 0 minus 1, so that's -1. -3 would be 1, so it's 3 minus 1 is 2. Plugging in a 4, that's 8. Cube root 8 is 2. 6 minus 1 is 5. Okay? And then you just plot those, knowing this is a cube root. For those of you that want to do it this way, and again, so I'm giving you 2 options here, and you do whichever one makes more sense to you. So if you liked this one, then you're just going to shift every point left 4, down 1, okay? Your choice. All right, we're definitely going to have to go by 2s here. So -12, -7 if you're doing it in one shot. Just be careful when you have odd numbers with even tick marks. But then remember, cube roots have the same general shape. Okay, then I want you guys to try one more problem. You have space there, okay? We'll just do it right here. Did everybody get this, no matter which way you did it? Okay, great. All right, we'll call this example 7. I want you to graph, it's y equals 3 times the square root of x plus 1 minus 5, and then state the domain and range. Okay, I'll give you a head start on me. So if you're trying the more advanced way, your square root table is 0, 1, 4, 9. But this is left 1. So that means I'm taking each of those x values and moving them left 1, so I can do it in one graph. I personally prefer this way, but you choose either. Now remember with the square root graph, don't make it shooting up, okay, because it levels off. And then I can figure out the range that y is greater than or equal to -5. Any questions on that?